going to start off first talking about the profile of the Thalmann long folder. What we have is a unique shape that works great for the North American industry. You have an upper beam that's curved, and that's great for J-channel, overhead door flashing, gutters, downspouts. Makes it so much easier to pull the part right off. The other feature that we have is the folding beam. It's relieved and it goes back at an angle of 110 degrees. The reason why we have that is, one, the linkages don't have to go as far, and when we work the folding beam you'll see that. But two is the linkages work in elliptical fashion to give you an accurate radius, not a half moon radius. The other item is the lower beam. If you notice, there is no geometry right here to get in the way if you had some down flanges. Beam also gives you strength, more strength. Anytime you put a bend in material, it strengthens that. The stroke of the upper beam is 7.5 inches. So when you're trying to pull a part out, it gives you lots of area. You're going to minimize this in your program based on what you're forming. But when you do need to pull the part out, you got plenty of space. The clamping of the upper beam comes on the OSHA pinch roll, and then when you fold it, we get 144 degrees for our overlap, not for the folder. So what that gives you is the linkages are able to get a true elliptical form for forming. This is fantastic for doing grade E material. Grade E material will spring back a lot. A lot of times you're springing back about 20, sometimes 25 degrees. Grade E material can go from 80 thousandths tensile to truly bending at 110 thousandths tensile. On a Thalmann, if you notice, the linkage is very compact. We use hardened links and hardened pins. One of the pins is a shear pin. If someone is doing, let's say this machine's a 16 gauge, and if someone is trying to do 11 gauge, it's going to try to start bending it. But the shear pin will shear rather than destroy the linkage or the folder itself. On every C-frame, we have the linkage. Folding beam has a torsion shaft. This is unique to all Thalmanns. Doesn't matter if you're looking at an 18 gauge or 11 gauge folder from Thalmann. They always have a folding beam torsion shaft. All the cylinders are connected to the torsion shaft. Then the linkages are connected to the torsion shaft. So what happens is, today you're running a machine, and then 20 years from now you're running a machine. One cylinder might be working a little bit different than the other, but with the torsion shaft you're getting even distribution across the whole length of the machine. Torsion shaft, all long folders on a Thalmann have a torsion shaft on the upper beam. The reason why is we keep parallelism across the upper beam for clamping and for hemming. We don't have a relief in the upper beam for open hem. We can open hem to a dimension. And the reason why we can do that is we keep parallelism across the machine. But also, the movement of it, you can see that these cylinders are connected to the torsion shaft, and they cause the upper beam to move in a parallel movement. The thing we're going to talk about is back gauge. Back gauge has a standard on this 18 gauge and 16 gauge with 49-inch stroke all the way to 1/4 inch. The movement, as you can see, we're in manual mode, so it's a little bit slower here. In automatic mode, it's faster, but I want to show you that the machine runs on THK linear wave, the back gauge. Another feature that we have is our small parts back gauge, located very close to the control, so the operator is able to do adjustments on the back gauge and the control without being in the middle of the machine. We can do this because the torsion shaft on the folding beam keeps the parallels. Another standard feature that we have on the all the Thalmann folders is the crowning. The crowning is adjustable by moving this wrench front to back. If you notice, if I turn it clockwise, I'm going to overbend more, and if I turn it counterclockwise, I underbend more. Fantastic feature for doing radius parts.